Imagine you are 3 years old. You have never been to this street before. Your parents have never brought you here. And yet, you walk straight to a house, point at the front door, and say, "That's my room. That's where I used to sleep." You are not playing a game. You are not repeating something you heard. You are completely certain. Now imagine that the family who used to live there confirms every single detail you just described. The bedroom, the color of the walls, the name of the dog, things no one told you, things no one could have told you. This is not a movie. This is not a ghost story from a campfire. This happened. It was documented. And scientists, real scientists at one of the most respected universities in the United States, could not explain it away. So what exactly is going on? And what does it mean for everything we think we know about life, death, and the nature of the human mind? Here is the question that has been quietly terrifying researchers for over 60 years. What if some children are born with memories that do not belong to them? Not imagined memories, not learned memories, specific, verifiable, falsifiable memories of people who lived and died before those children were born. The case that started it all is both simple and deeply unsettling. In 1957, in a small town in England called Hexham, 2 young sisters were killed in a tragic road accident. Their names were Joanna and Jacqueline Pollock. They were 6 and 11 years old. Their parents were devastated. Then, about a year later, their mother became pregnant again. Twins. 2 girls. And as those girls grew old enough to speak, something strange began to happen. They started describing things they should have had no way of knowing. The layout of a school they had never attended. The location of a park in a town they had never visited. The names of toys belonging to the sisters who had died. When their father took them to Hexham, for the first time, as far as the parents knew, the girls navigated the streets with total confidence. They pointed out their old school. They found the playground. They recognized their old home. The father, John Pollock, was a devout Catholic who believed in reincarnation. But researchers who later studied the case were not religious. They were scientists. And they were baffled. This case, and thousands like it, became the foundation of one of the strangest and most serious research programs in modern academic history. The central question it asks is one that science has never fully answered. Where does consciousness go when we die? In 1961, a psychiatrist at the University of Virginia named Dr. Ian Stevenson decided to do something almost no credentialed scientist had done before. He decided to take children's claims of past life memories seriously, not as spiritual testimony, but as scientific data. He treated each case the way a detective would treat a witness statement. He interviewed the children. He interviewed their families. He traveled, sometimes thousands of miles, to verify specific claims against historical records. He looked for ways to debunk what the children said. And when he could not debunk them, he documented them. Stevenson spent over 40 years on this research. By the time he retired, he had personally investigated more than 3,000 cases from over 40 countries. He published his findings in peer-reviewed academic journals and in detailed books. His methodology was rigorous. He categorized cases by the strength of verifiable details, names, locations, causes of death, physical birthmarks that seemed to correspond to wounds suffered by the claimed previous person. Yes, birthmarks. In several cases, children who described dying from a gunshot wound to the head were born with a birthmark in the precise location they described. Stevenson documented over 200 of these cases with medical records and photographs. After Stevenson's death in 2007, his work was continued by Dr. Jim Tucker, also at the University of Virginia. Tucker has now cataloged over 2,500 cases in the university's database, and that number keeps growing. Tucker's approach adds a modern scientific lens. He has explored whether quantum mechanics could offer any framework for understanding how information, what we might loosely call memory or consciousness, could theoretically persist beyond the death of a physical brain. He is not claiming reincarnation is real in a religious sense. He is saying, the data exists, it cannot be easily dismissed, and mainstream science has not given us a satisfying explanation for it. The cases that are hardest to explain share specific features. The child begins speaking about a previous life between the ages of 2 and 5. The memories fade, usually completely, by the age of 7 or 8. The child describes a specific person, often a violent or sudden death. The most compelling cases involve children who have never had access to information about the person they claim to have been. No internet searches, no family connections, no books in the house. And in a significant number of verified cases, researchers have confirmed that the person the child described actually existed, died in the way the child described, and that the details the child gave were accurate, sometimes down to obscure personal habits and physical descriptions of their home. Mainstream neuroscience has largely ignored this research. The dominant view is that memory is a product of brain activity, full stop. When the brain dies, memory ends. But Stevenson's and Tucker's data creates a genuinely uncomfortable problem. If memory is only a brain phenomenon, how do you explain a 2-year-old in Sri Lanka accurately describing the interior of a house in a village 60 miles away, where a man named with a specific name died in a specific way, years before that child was born, and being confirmed correct on every verifiable point? The scientific community does not have a clean answer. That silence is itself a data point. So let's go somewhere bold. Let's ask, what if this is real? What if some form of information, some fragment of identity, experience, or memory actually does survive the death of a physical brain and reemerges in a new one? What would that mean? First, it would completely rewrite our understanding of consciousness. Right now, the dominant scientific model treats consciousness as an emergent property of brain activity, like how wetness emerges from water molecules, even though no single molecule is wet. The brain generates experience the way a lamp generates light. Turn off the lamp, light disappears. Simple. But what if consciousness is not the lamp? What if consciousness is more like a signal, something the brain receives and amplifies, rather than something it creates from scratch? This idea is not new. The philosopher Henry Bergson proposed something like it over a century ago. More recently, physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed a controversial but serious theory called orchestrated objective reduction, or ORCHOR, which suggests that quantum processes inside brain cells called microtubules might be the physical basis of consciousness. And crucially, quantum information has a property that classical information does not. It cannot be simply destroyed. In quantum mechanics, information is theoretically conserved. It transforms, it disperses, but it does not vanish. Now, no one is claiming this proves reincarnation, but it opens a door. If consciousness has a quantum substrate, and if quantum information cannot be destroyed, then the question of what happens to consciousness after death becomes a legitimate physics problem, not just a philosophical one. Science fiction has been sitting with this idea for decades. From the uploaded minds in Altered Carbon to the soul transfer technology in Black Mirror's San Junipero, these stories are not just entertainment. They are thought experiments about what personhood actually is. Is it the body? The brain? The pattern of memories and connections? If it is the pattern, if you are fundamentally a structure of information rather than a structure of matter, then the idea of that pattern persisting, shifting, re-emerging somewhere else becomes less like fantasy and more like an engineering problem. What if the children in Stevenson's database are not supernatural anomalies? What if they are, in the most literal sense possible, living evidence of a natural process we do not yet have the instruments to measure? What if memory is not stored only in neurons, but somewhere we have not looked yet? Here is where we have to be honest. Because as compelling as all of this is, the skeptics are not wrong to be skeptical. And if you care about science, really care about it, you have to sit with the counterargument seriously. The first problem is methodology. Even Stevenson's most rigorous cases involve human testimony, parents, relatives, community members. Human beings are extraordinarily good at unconsciously shaping narratives. A child says something vague. A parent fills in the detail. A researcher hears the filled-in version, and suddenly a loose resemblance becomes an eerie confirmation. This is not dishonesty. It is just how human memory and storytelling work. Psychologists call it confirmation bias and source monitoring error. Both are well documented and both are almost impossible to fully eliminate in field research with young children. The second problem is cultural context. The vast majority of strong reincarnation memory cases come from cultures where reincarnation is an accepted belief: South Asia, West Africa, parts of the Middle East. In cultures where reincarnation is not a social concept, such cases are far rarer. Critics argue this is not because reincarnation actually happens more often in those regions, but because in those cultures, parents are more likely to take a child's strange statement seriously, repeat it, record it, and eventually contact a researcher. In Western secular environments, the same child might be gently told to stop making things up. So are we measuring a real phenomenon, or measuring a cultural filtering system? The third and perhaps most fundamental problem is this: not a single one of these cases provides what scientists call a causal mechanism. We have no physical model, not even a speculative quantum one, that explains how information from a dead person's brain could encode itself into the developing brain of an unborn child who has no biological connection to that person. Quantum consciousness theories are fascinating, but they remain deeply controversial even within physics. Penrose and Hameroff's Orchard model has been criticized sharply by mainstream neuroscientists and quantum physicists alike. Saying quantum information cannot be destroyed is true in a formal sense, but translating that into a mechanism for memory transfer between biological organisms is a very large leap. And the University of Virginia database, as carefully compiled as it is a collection of cases, not a controlled experiment. There is no control group. There is no replication protocol. There is no double-blind design. These are not criticisms of the researcher's honesty. They are structural limits of the research domain itself. The phenomenon, if it is a phenomenon, does not cooperate with laboratory conditions. That does not make it real. It also does not make it fake. It makes it genuinely, stubbornly, frustratingly unresolved. Here is what I keep coming back to. Science is not a list of answers. Science is a method for asking better questions. And the question that Ian Stevenson and Jim Tucker have been asking, quietly, carefully, for over 6 decades, is one of the most important questions a human being can ask. What are we really? Not what are our bodies made of? Not how do our neurons fire? But what is the thing that experiences being alive? Where does it come from? Where does it go? We do not know. That is the honest answer. We do not know. And the reason that answer is worth sitting with, rather than dismissing or blindly accepting, is that the shape of the unknown matters. The fact that over 2,500 documented cases exist that have not been cleanly explained by any mainstream scientific framework is not proof of reincarnation. But it is proof that our current models of consciousness have gaps. Big ones. And in science, the gaps are where the real discoveries lie. The children in these cases, the twins in England, the 3-year-old who picked up the right toy, the boy in Sri Lanka who described a life he never saw, they are not data points to win an argument with. They are windows. Small, imperfect, hard to interpret windows. But they face a direction that most of science has never looked. What is on the other side? We are only beginning to find out. And maybe that is exactly why it matters. Not because we have the answer, but because we finally have the courage to ask the question without laughing it off. The universe is stranger than our textbooks. These children might just be the proof. If this video made you think, even a little, about what consciousness really is and what might lie beyond what we currently understand, then this channel is exactly where you belong. We explore the edge between hard science and science fiction every single week. Real research, real mystery, real questions that do not have easy answers. Subscribe to Sci-Fi Experiment Lab and turn on notifications so you never miss an episode. And drop your thoughts in the comments. Do you think there is something to these cases, or is there a better explanation? I read every comment. Let's figure this out together.